Hi everyone, we're going to discuss the polar equation and graph by hand. The first thing you need to know is the form for the polar equation should be EP over 1 plus E sine of theta. Because we need to find P and E. And the first thing we notice is this is not a 1. So what I'm going to do is factor out a 4 in the denominator to help us out here. So this is going to be 1 plus, this is going to turn to 3/4 sine of theta. Now, I also notice that I can simplify. 4 goes into 8 2 times. So there's my new equation. So write everything out. We have EP equals 2, and our E equals 3/4. So EP, we need to know EP is 2. So 3/4 times P equals 2. When you multiply by the reciprocal 4/3, you're going to get P equals 8 over 3. So basically all this tells us that since E is 3/4, that's less than 1, that we have an ellipse. Okay, the directrix is above the pole. It's parallel because it's sine. So directrix is above the polar axis. It's parallel to the let me write it the right way. It's parallel to the polar axis, and it's the P part is it's the distance. So it's 8/3 units above the pole. All right. So basically, let me go over here and we're going to graph it. And let me rewrite the equation here in the correct form. So we had 1 plus 3/4 sine of theta. And basically what we know is the directrix is parallel to the polar axis. The polar axis is actually this x-axis by 8 over 3, which is, stop. Alright, so it's 8 over 3 is a little bigger than 2, so I'll put it right about here. So here's your directrix. Now that means the focus, or the foci, is going to be along the y-axis here. So the focus is going to be somewhere in this vertical part. Now, here's your pole. And to find, and we're using polar coordinates now. Remember, r, comma, theta. I'm going to be using 0, pi over 2, pi, and 3 pi over 2 to find key points. And I'm going to plug them into this equation. And so I'm first going to use these two. So basically, when you plug in pi over 2, sine of pi over 2 is 1. So you have 2r equals 2 over 1 plus 3/4 times 1. And this simplifies to 8 over 7. So basically we have a vertex. 8 over 7 is a little bigger than 1. So at pi over 2, we have 8/7 for our r. Alright, now let's do 3 pi over 2. Now 3 pi over 2 just means sine of 3 pi over 2 is -1. So I plug in a -1 here. And that's going to yield 8 when you simplify. So we go down, this is 3 pi over 2. This is the axis for 3 pi over 2. And go down 8. So 1, 2, 3, 4, 5, 6, 7, 8. So there's your other vertex. Alright? Now to get the x part, I'm going to plug in 0. Well, sine of 0, and I don't have a lot of room here, so I'm going to just erase this. Sine of 0 and sine of pi is 0. So basically what you're going to get is when you plug in 0, you get 2 over 1 plus 3/4 times 0 is just 0. So it's just 2. So at pi over 2, we're going over 2. So this would be 2 comma pi. That's this length. And at 0, you go over 2 this way. Alright? Now, I'm going to connect the vertices or the here and just connect everything. There's your ellipse. And sorry it looks funny, but that's as good as I can go. Alright, now we know the length of this is A, right? 2A is the length of this. But if I want to find the length of this, that's going to be 1/2 of A plus 8 over 7. So basically, to find A, this equals 32 over 7. So the center is at 8 minus 32 over 7, which equals 24 over 7. And what is that? 4, 3. So it's in between 3 and 4 here. 1, 2, 3. So the center is in here. Let me see. 1, 8, 7. So somewhere in here. And that would be right here is 24 over 7, comma 3 pi over 2. Because we're on this axis here. And then for the C part, the foci, C is actually 24 over 7 minus 0, which is 24 over 7. So our one focus is at 24 over 7. Comma, let's see, the second focus is going to be 24 plus 24 over 7, 3 pi over 2. So that's going to be 48 over 7, 3 pi over 2. So basically, my focuses are, let me put them in red, here at 0. And then we also have right about here, little higher. And there's your ellipse. Thank you and have a nice day. Bye-bye.